Okay, so this is going to be the video on conditional probability. So conditional probability, basically we have event B occurring, and then another event's going to occur that has already occurred. So they're going to be dependent on each other. They're going to be, if one's occurring, that means the other one is. So for any two events A and B, this is going to be our general equation that we're going to use a little bit later in the lesson. Okay, so first off, what is the probability that they are female and they are in graduate school? So I match where there is female in graduate school. And I want the total out of the entire graduate school. So I want to add these two together to get 3,303, which would be roughly 0.59 or 59% of the females are in graduate school. Okay, what is the probability that they are female? So I want the total number of females over the total number of students. Okay, so my total number of females is, if I add up this whole column, it's 9933. My total number of students, if I add up all my females and males, is going to be this. And then when I divide them, it's going to be around 57% of them are female. Okay, my next one here, I am doing a four-year college and a male. So first on top I match it, so my four-year college in males. So 4, 3, 2, 4. And then I want my total number of males that are happening in this, so I could figure out the percentage, or the decimal or percentage, I guess, if of the males are in a four-year college. So when I add up all my males here, it is 7,539. which gets me about 57% of them are in a four-year college. Okay, my next one, Americans recycle increasing amounts through municipal waste collection. The table shows the collection data for 2007. What is the probability that a sample of recycled waste is paper? Okay, so first I need to find my recycled paper amount, so 45.2. And I want to figure out what percentage of that paper in the recycled column is recycled compared to everything else. So I want my total recycled to go on the bottom because I want to figure out which percentage of that is going to be paper. So I put my total, it is 79.4 when I add up that whole column, and it's going to equal 57%. So 50% of the recyclables are paper. Okay, a utility company asks 50 of its customers whether they pay bills online or by mail. What is the probability that a customer pays the bill online given that the customer is male? So I need the mail and the online. So I know it's 12 out of how many people? Okay, so this one's a little trickier because it's giving you this weird piece of information. So it's 12 of the 50, and then it's going to be over the, so that was the probability of a mail and online. And then I need the probability of the total males on the bottom. So my total males is going to be 20 over 50. So this one's a little weird because I'm giving you this weird total in here. We won't have a whole lot of questions like this, just to be wary of it. Okay, so my total amount is going to be 0.6 or 60%. Okay, we also have tree diagrams. So a school system compiled the following information from a survey it sent to people who were juniors and 10 years earlier. 85% of the students graduated from high school. Of the students who graduated from high school, 90% are happy with their present jobs. Of the students who didn't graduate, 60% are happy with their jobs. Okay, so a tree diagram is going to branch off. So my first is they graduated or didn't graduate. So yes, they did. No, they didn't. So it looks like 85% did. That means I have 0.15% that didn't. My next part, the ones who graduated, 90% are happy. So we have happy and we have sad. So 0.9 are happy, which means I have 0.1 left out of that total 100% that are going to be sad. This one, it is 60% that are happy, which leaves me with 40% that are not happy. So to be able to find the question that I forgot to type in, we're trying to find the probability that they graduated from high school and are happy with present job. So graduated and are happy. So to find this, what we're actually going to do is just multiply those parts of the tree branch together. So I'm going to find the part that graduated and the part that is happy, and I'm going to multiply them. So 0.85 times 0.9 to find the probability of the total, which is going to be 0.765, which would be 76.5% of them are happy and have graduated.